Teaching and learning through observation. Consciously using observation is just as important to teachers as it is to scientists and other professionals. Observing helps construct reality and make sense of the classroom environment. Observation is the fundamental tool for teachers just as it is for scientists and other professionals because it helps them to construct reality and make sense of the classroom environment. By carefully observing students, teachers gain insight into their learning styles, behaviors, and interaction. This enables them to adjust their teaching strategies and provide individualized support and create more effective learning environment. Observation allows teachers to notice patterns, identify challenges, and assess students' progress beyond test scores. For example, by watching how students approach a task, teachers can determine whether they need more guidance if they are engaged or if they are struggling with a concept. This real-time feedback helps educators make informed decisions about lesson-facing classroom management and instructional methods. Observation fosters a deeper understanding of the classroom dynamics such as students' engagement, for relationship, and social emotional development. A teacher who observes a student is hesitant to participate in group work can take steps to build their confidence and encourage collaboration. Just as scientists use observation to form hypotheses and draw conclusions, teachers use to refine their teaching and create meaningful learning experience. When used consciously, observation transforms the classroom into a space where teaching is responsive, adaptive, and centered around students' needs. What is the importance of observation? The development of facts from observation. Why are the observations important to scientists? Usually, they attempt to find the answer to question by looking for patterns in nature, numbers, or controlled experiments. Observation is crucial in science because it allows scientists to collect data, recognize patterns, and develop explanation for natural phenomena. By carefully observing and recording events, scientists can test hypotheses, identify relationships, and build theories. The development of facts from observation. Observation provides the raw data needed to establish scientific facts. Scientists use systematic observation to gather measurable and repeatable information. This data forms the foundation of developing theories and laws in science. Why are observation important to scientists? Identifying patterns in nature. Scientists observe recurring events or trends in natural systems. For example, early astronomers noticed the regular motion of planets, which lead to the development of planetary motion laws. Using numbers to detect trends. Many scientific observations involve measurements and data collection. For example, biologists might track animal population over time to identify trends in ecosystem. Controlled experiments. Observation in controlled experiments help scientists test hypotheses by isolating variables. For instance, in medical research, scientists observe how a new drug affects patients compared to a placebo group. The development of concepts from observational facts. A new view of education is taking shape that reflects science as the understanding relationship between systems and their parts. The development of concepts from observational facts is fundamental to scientific thinking and education. A new perspective on education is emerging, emphasizing science as the study of relationship between systems and their components. This approach shifts from rote memorization of isolated facts to a deeper understanding of how different elements interact within a system. For example, in biology, instead of merely learning the names of organs, students explore how the circulatory, respiratory, and nervous system work together. Similarly, in physics, understanding motion requires studying the interaction between force, energy, and mass rather than just learning formulas. By focusing on the relationship within system, this educational approach helps students develop critical thinking, problem-solving skills, and ability to apply knowledge in real-world situations, encourage them to observe, analyze, and form concepts based on evidence, much like scientists do. This way, education becomes more dynamic, fostering and deeper understanding rather than passive knowledge of absorption. Indirect observation. Most of the time, we collect data through direct observations. In other science disciplines, including biology, chemistry, and physics, There are instances wherein we rely on indirect observation. Indirect observations occur when scientists gather data about a phenomenon without directly experiencing or measuring it. Instead, they infer information based on evidence, models, or the effects of the phenomenon on the other system. Indirect observation is essential in many scientific disciplines, especially when direct measurement is impossible, impractical, or too dangerous. Example in different sciences. Biology. Scientists study microscopic organisms like viruses or deep-sea creatures. Through genetic analysis, chemical trace, or image from specialized equipment rather than direct observation. Chemistry. The structure of atoms and molecules is determined using inferred from chemical reaction since atoms are too small to be seen directly. Physics. Astronomers study distant planets, stars, and black holes by analyzing their light, spectra, gravitational effects, or cosmic radiation as direct contact is impossible. Indirect observation allows scientists to expand knowledge beyond what is immediately visible using logical reasoning, technology, and experimentation to uncover hidden aspects of nature.